I want to use this question as an example to illustrate how to use Excel to calculate a payback period and PVA, PI, and IRR. You are considering a project with an initial cash outlay of $75,000 and expected free cash flows of $25,000 at the end of each year for 5 years. The required rate of return for this project is 8%. So let me put down the information in my worksheet. So the first column is the year, and the second column is the cash flow. Right, so the current time period is 0, and the cash flow is, as we were told, this is cash outlay, right? So 75,000. So this is a negative number. And so starting from year 1, and you can see this continues for how many years? Just going back and look at the setup. So for 5 years, right, this goes on for 5 years. So it's going to be up here. And the annual cash flows will be $25,000. $25,000. So just put this for the every year. And finally, it's the discount rate. Discount rate is gonna be just put it here. So I guess we were told this is 8%. Right, this is 8%. Okay, so why don't I just put one more column, maybe 2 more columns. So the first is to calculate a payback period. We know that payback period is basically the number of years or number of periods it takes for the project to pay back. What does it mean by paying back? It simply means that the sum of the um, future cash flows is enough to cover the initial cash outlay. So in order to do that, let me calculate the cumulative cash flow balance. And we know that for the payback period, we don't have to do the discounting. That's actually one of the disadvantages of using this decision-making rule, because it doesn't consider basically risk, right, and doesn't consider the time value of money, and both will involve discounting the future cash flow. So now I'm just calculating the cumulative cash flow balance by summing up the cash flow across the years. So for the current year, which is 0, just the first cash outlay, and starting from year 1, I want to do the summation function equals sum and open it. You can see that basically is the sum of a series of numbers. So the first number is basically the cash outlay, and this is up until year 1. So I'm just gonna press the shift and pull the cell down to year 1. But I want to do a small trick here by fixing the cell value. Why do I do that? Because I want to calculate the cumulative balance, cash flow balance, for all the years. So I can do this here. You can see this for this year. Actually, I don't need to add this dollar sign. Basically, by adding the dollar signs, I fixed the cell. But if I don't do that, and when I drag the cell to the other years, you can see that because I already did that, so if I don't add the dollar sign, when I drag the cell, the summation will also go rather from starting from year 0, it will also shift 1 year later. So just go sequentially. So that's not what I want. Basically, I want to fix the starting year. So that's why I want to fix this the sale value here. And now you can see when I drag the sale all the way down to the last year, you can see, for example, for the year 2, this is sum of B2, which is the starting cash outlay, and to B4, which is the year 2's cash flow. So by this, you can see that this is actually very easy to see because by year 3, the sum of the cash balance exactly equals 0. So this simply tells me the payback period is actually exactly equal to 3. But sometimes, for example, if I just change the number here to be, let's say, change this to be 45 rather than 30 rather than $25,000 for year 3's cash flow. And now you can see this changes to $20,000. So that means if we add up the total cash flow for year 3, by the end of year 3, the cumulative cash balance will exceed 0. So that simply tells me that the payback period for this project should lie between year 2 and 3, right? Because by year 2, the cumulative balance is still negative, but by year 3, it becomes positive. So the cumulative balance being 0 must happen between year 2 and year 3. So by how much, we can also do that calculation by knowing that because by the end of year 2, the cumulative sum of the cash balance is still negative $25,000. So that means we need $25,000 from year 3 to cover this negative sum. And let's assume that the cash flows happen evenly across the year, because the total year, over the entire year, the total cash flow we're going to receive is $45,000, but we will only need $25,000 in order to cover the net sum, the sum of the cumulative balance before this year. So that means we will need equals 25,000. That's how much we need, and that's how much we have here for the entire year. So the ratio of these two numbers will give us the fractional number of years in order within year 3, right? That's still between year 2 and year 3, but that's a fractional number of years, which will be enough to cover this cash balance, negative cash balance, which will, in other words, which will be enough to break even. So that's the definition, basically, of the payback period. So in this case, the payback period should simply be 2 plus this number, right, the fractional number. So it's 2.56 if the cash flow of year 3 changes to $45,000. But in this case, actually, let me just undo what I just did. The actual cash flow here is $25,000. So that means our payback period for this project actually is exactly equal to 3. So I'm just gonna put that as the answer, 3, and check my answer here. Excellent. And the project's NPV is, so to calculate NPV, so let me calculate NPV here. I can use the sort of the NPV function, but one thing about this NPV function is that actually it only calculates the present value of all future cash flows, because we know that NPV means net present value. The word net here means that it is the present value of all future cash flows net of the initial cash outlay. But the NPV function in Excel actually only does the first part. the present value of all future cash flows. It doesn't net out the initial outlay. So we need to do that manually. So that's the thing we need to remember when we use this function. So equals NPV and read is right here. Just can put the discount rate, and you can see the other arguments is value 1, value 2, value 3. This simply means it's the cash flow starting from year 1, because as we said, this only calculates the present value of all future cash flows. So these cash flows need to start from year 1. So we're gonna put this, point our mouse to year 1's cash flow and drag the cell all the way down to the last year's cash flow. And then we can close this. And then the final step is just to go back and check the rounding requirement. Here it rounds to the nearest cent. I think that's what we did, right? We just basically follow that by keeping 2 decimal places. So we can just copy the number back and get rid of the dollar sign because we already have a dollar sign here. So I check my answer. Oh, actually, I think I forgot to do what I preached you guys to do by summing up the initial cash outlay. Right, so that's basically because I said NPV function is to calculate the present value of all future cash flows. So basically, I need to add. The reason I add is because the sign on the cash flow is already taken care of here. So I just add the initial outlay. If the initial outlay is put here as a positive number, then I need to subtract the initial outlay. So I'm gonna do that again. So this should be the correct answer. Sorry for the trouble. This probably brings to you, so it's confusing. And check my answer again. Good job. And then the project PI. So once we understand how the NPV function works, and we know that PI basically is defined to be the present value of all future cash flows divided by the initial cash outlay. So the NPV function basically calculates the present value of all future cash flows. So I'm gonna just use that as the numerator. Right, so just taking this, that's the same as what we did for the NPV, but then rather than adding the initial cash outlay, we are dividing the initial cash outlay. But because the initial cash outlay is a negative number, so we need to add a negative number, a negative sign in front of this to get rid of the negative sign, basically. So, and this will give me, if I keep 2 decimal places, I think that's what it requires. And this will give me 1.33. Right, so, it's actually round to 3 decimal places. So it's always a good habit and to check the rounding requirement. So this will be 1.331. Okay, so fantastic. And the last part is the project IRR. So for IRR, I don't need the discount rate because IRR is basically the discount rate which makes the NPV to be 0. So in Excel, there's also a function called IRR. But compared with NPV function in Excel, we know that NPV function only calculates actually the present value of all future cash flows. But IRR is different. IRR, you can see once you open this function, it only has, the arguments only have values. Basically, values are cash flows. But here, we need to start from the beginning, start from the year 0. And then drag the cell all the way down to the last year's cash flow. And the second argument you can see it's guess. Basically, this is the initial guess for the IRR function in order for Excel to start to look for that special discount rate, which makes NPV to be 0. because that's the definition of IRR. And if you don't put this guess value, Excel will start from 10%. In this case, we know there's only one IRR possible. Why? Because the maximum number of IRR, as we learned in this chapter, is basically the number of times the cash flows switch signs. But in this case, the cash flow only switch signs once, right, from negative to positive and stay positive. So there can be only one possible IRR. In that case, we don't have to worry too much about the guess value, the initial trial value. So we just put that, and then it gives us 20%. But we need to be very careful and go back and check the rounding requirement, round to 2 decimal places, and now change the format of the cell and keep 2 decimal places. So now once you keep 2 decimal places, you can see that the number changes to 19.86%. So that means the reason we got 20% earlier was because we kept 0 decimal place. So now that should be the correct answer, 19.86%. And check my answer. We're done.